Okay, now that you have some practice creating graphical displays for your quantitative variables, again, those are either a stem plot or a dot plot or a histogram, the next step we need to take is to be able to describe what that graphical display tells you about the data. So this is just the first portion of this discussion. We'll also be talking about this in the next few lessons as well. So whenever you're trying to describe a distribution, the very first thing you want to do is see if there are any overall patterns or any deviations from that pattern in the data. And the best way to do that is to take a look at the overall shape of the distribution, which we'll talk a little bit more about in just a moment. When you take the AP exam in May, I can pretty much guarantee that there will be a question on the exam that's going to ask you to compare two distributions. And whenever you answer a question like that, what that means is that you want to be able to describe both of the distributions and then say what's a little bit different about them. And anytime you want to describe a distribution, you're going to want to talk about three things: the shape, the center, and the spread. In this lesson, we're going to talk a little bit more about how you can describe the shape, and then we're going to save discussing, talking about the center and the spread of a distribution for a subsequent lesson in a couple of days. So once you've described the shape, the center, and the spread of your distribution, the third thing you want to do when you're talking about your distribution is you want to identify any outliers, and we'll also talk about what an outlier is in just a moment. But first, let's talk about the shape of a distribution. So first off, when you're talking about the shape, you want to decide if there are any peaks to your distribution. If there is one peak, also known as one mode, that means your distribution is unimodal, uni for one. If you have two peaks in your distribution, then we say that your distribution is bimodal. Bi for two, of course. A third possibility, which you probably won't see very often, but which could occur, is that there aren't really any peaks at all, and not even any sort of variation in your data. And if that's the case, then we say that you have a uniform distribution, which you can see what its general shape would be down at the bottom of the slide. But again, you probably won't see a uniform distribution very often. So once you've taken a look to see whether there are any peaks in the overall shape of your distribution, you also want to say whether your distribution is symmetric or skewed. Now, a symmetric distribution looks just the way it sounds. We know what symmetry is. What happens on the left also happens on the right. So this would be an example of a distribution that's almost symmetric, except I can't draw very well. The other possibility is that you have a skewed distribution. So instead of having about the same thing happening on both sides of your distribution, you have more of your data collected to either side. So there are two possibilities. Your distribution could be skewed to the right. So that's no good. So let's see, it would look something like this. So that is a distribution that is skewed to the right. And then the opposite of that would be a distribution that is skewed to the left, which would look something like this. Now, I always get confused, and I want to mix these two up. So here's how I remember it. This part over here in this top distribution that's skewed to the right, we call this the tail. And the direction that the tail is pointing tells you which direction that your data is going to be skewed. So because we've got our tail over here on the right side of this top distribution, that means that our distribution is scaled to the right. And just the opposite is true of our distribution on the bottom. Because our tail is pointed to the left, we've got a distribution that is skewed to the left. And it will be important to be able to distinguish between skewed to the right and skewed to the left, because you certainly would not want to mix those two up on the AP test. Okay, so the very last thing that we need to talk about is this idea of outliers, and we'll be covering this in a little more detail in subsequent lessons, but I just want to give you a real quick explanation of what an outlier is. And you've probably heard this term before. An outlier is simply a data point, or maybe you have several data points that lie far away from the rest of your data. So I'll just draw a quick histogram example of what this might look like. So perhaps you have lots of data over here in this range, and then for some reason something crazy's happened and you have one little data point that shows up way far away to the right of the rest of your data. Obviously this is some sort of odd situation. There may be some explanation for why your little data point ended up so far over to the right. Maybe that data point was not measured correctly. Maybe if you're measuring heights, you just have a freakishly tall person. So you need to think about your data in context to decide whether or not you want to continue to consider including that outlier in with the rest of your data. And we will talk about the effects of outliers and what they do to what we call measures of central tendency in subsequent lessons as well.